Hello, we are live again. Hello, 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 hello. Let me know how it sounds because I switched computers. Let's see. I'm tweaking my microphone. I don't want to do that. Really, I don't want to tweak it that much. Let me know how it sounds. Hello, 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 hello. Let me know if it sounds okay. Properties. Hello everyone who's here. Let's put a gain filter on this thing. Hello, 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 hello. I don't want to put too much on this. Close. All right, I think that's good. I think that's good. It's a little bit far. I think that's good there. All right. Alrighty. Hey, Miguel Ortiz. What's up, Miguel? Fedor. Hello. Felipe. What's up, Bob? Everyone. What's up? So happy to have you guys here. Welcome to another live stream. Look at my hair. It's cool. And you notice that I'm in a new office. Look at that. New office. Hey, Steven. What's up? Not really. It's not really a new office. I know I didn't get you there, guys, but it's the same office. But before I was looking, I was looking to that side. Now I put everything against the wall, which is not what I wanted to do. I really wanted to avoid looking at a freaking wall, but it's better. The space is used better this way. I had to move because this thing it's more crowded. I have another desktop there, have another desktop over there, another workstation, etc. So I had to move stuff around so I don't so I actually take advantage of my space properly, and yeah, and I love the way it is. It's awesome. You can see Woody over there. Woody, it's there, and Bob, SpongeBob's there, and the Super Mario Brothers are there. Cool. Hey Tim. Yeah, I'm glad you're excited about Fridge Notes. Hey Kishaw, you like the view? Yeah, it's good. It's good. It's a good view. And the space it's good. It's a nice space. And you can see a dog there. That's my dog Bruno. He's sleeping. He doesn't care how much noise you make. And there's an emoji there. Some books, printer, etc. Some beers. I'm gonna do something else with this wall. I wanna do something else with this wall, so I'm not gonna put guitars there. I wanna have a really nice lamp there, and I wanna have some design on this wall, but I haven't done it, so that's what I want to do for that wall. My dog it's quiet unless somebody is at the door and he starts barking. That's what he hates. People. He hates people. And dogs. He hates everyone. All right, so today we're gonna learn about for each nodes, which a lot of people find it confusing. I know I found them confusing when they were introduced. They are a little bit confusing. Let me stop moving my. So yeah, they are a little bit confusing when and I don't want to open that version of Houdini. So yeah, talking about that, you guys saw that hey Amos, what's up? You guys saw that Houdini 17 preview? Let's talk about, you know what? Let's talk about that first, because that is amazing. I've been upgrading everything because I switched the workstation that I showed you guys last week. I actually overclocked that, and now it's my main desktop. So being that I moved my desks and my computers and everything, I put it on I made the new workstation my main workstation. Now I'm using that right now. And it's pretty damn fast. It's awesome. It works really great. Once I overclock that Ryzen processor, it works pretty cool. Let's go to, I think, Houdini 17 preview. Was it preview? Sneak peek. It's called a sneak peek. So let's talk about that. You guys saw that? Oh my god. Let me entertain you. You can see it. Let's see it in whoa, YouTube. Let me turn the volume down. Alright, so let's see. Hey, Dova Diaz. Hi to Spain. Hey, yeah, well, this is like, these streams are an hour long because we just go through different topics and talk about stuff. We don't just stay in one topic, but yeah. I have thought about that, just getting some of these topics into chunks, and then but the good thing about these LearnDays is that you can ask questions. You can ask me questions directly, but if I make this into a 5-minute tutorial, you can't ask questions at all. So yeah. Hey Riz, what's up? Hey Riz, I'm still waiting for your email, dude. You should email me. All right, so let's talk about the Houdini sneak peek. There's so much stuff that I've been holding my mouth not to talk about, especially Bellum. Bellum is, oh my god, it's amazing. That cloth solver, look at that. That's a cloth solver there on the. So they start with grooming, which is great. Grooming it's way faster now, which is amazing. There's a lot of improvements on grooming, which is it's great. You can see that line looks amazing. There's nothing wrong with that line, and the physics are so good. Yeah, you can control the clamping so perfectly. It's really great. And inbuilt dynamics, which is great. Built-in dynamics for the hair, awesome. Just simply awesome. Looks amazing. So this is the I think this is one of the biggest things in Houdini 17 Bellum, which is GPU accelerated solver. This solver comes to solve the cloth thingy in Houdini, which a lot of people complain about being slow. So now with Bellum, it's just like Bellum is not slow. It's GPU accelerated. It's not slow, and you can see you can make those panels like those applications that you can design your clothes. So it is not there as marvelous designer, but it's going in that direction. You can see they you can generate the panels from curves. You can see there's just a panel there. You can there we go. We can advance frames. You can see that frame. You can make your panel just like a stitch panel will be for real. Like a marvelous designer does that really well. Marvelous designer it's really amazing by that. But you can see with that you can make your cloth panel and then just mirror it and decide where you want to stitch those guys. You can see those are stitches. And then you just sim that to fit it to the model, and you can see that this is an example of multiple layers of cloth, and it doesn't show the how the being simulated, but it's pretty fast. You can see this is another example there. You can see this is it's saying that it's 85,000 polygons, and it takes 70 seconds per frame, which is it's good. It's pretty cool. There's a lot of stuff being simulated there, and you can see you can simulate tearing as well, which is like, yeah, baby, tearing, please tear. And you can have all these visualizations of stuff, which I think there are parameters that you can control, I'm pretty sure, being Houdini. And also this is another thing about Vellum, that it's also a solver for wires. So it's a wire solver as well. So right here is calculating the wires here, these poles and those little strips that it's holding the cloths and the cloth. So it's calculating all those stuff, all those things together, and then you can rip them apart. You can see they are interacting with each other. It's now here is interacting with sand. The sand breaks the cloth, and that break looks pretty cool. Look at that. It breaks right there, which is awesome. Awesome. And this is something that a lot of people like to do, soft bodies that have pressure to do balloons, and you can see it conserves the correctly conserves the volume of it. So you can see here it's interacting with wire solver here. It says glue and tearing. So you can see now it's sticking to the spider web there, and it can actually rip this spider web as well, which is like awesome. You can also simulate plasticity for, in this example they're using it for the grass on the floor. You can see it's being deformed and it stays at that. Now this is a big one that I actually, it's like I've been trying to push this more and more. Character animation, it's huge in Houdini 17. All the stuff they are making for Houdini 17, it's amazing. Character animation needs coming to Houdini fully. I don't know why you will be doing your animation in another application that is not Houdini. After this release, it's just incredible. So you can see these guys are animated in Houdini. They are cloud agents. Sorry, I don't want to say that these are animated in Houdini. I'm not sure, but they are crowd agents. You can see the hair, it's simulator, it's pretty cool simulator. And this is the full body IK for posing stuff. Full body IK, which is great. Facial auto rigging. Come on, dude. Who has that out of the box? Who? Is there another application that has this out of the box? Because I know Maya has plugins for this stuff, but now Houdini has body and facial auto rigging. It's like, what? Really? And then pose or PSD, which is pose space deformation, which is amazing when you're rigging organic stuff and you want to have muscles behave in a specific way or correct. This is some people call it corrective modeling or something like that, because you can correct poses. Like there's another, like there, like in this area right here, you will try to correct that because it should bend maybe differently here. A good example is when you raise your arm, that it's always wrong with any kind of rigging. And there's an example here, actually. Here in this guy, you can see this is no correction, and you can see corrected has a lot of the muscle that should be there, corrected all the way here to the arm. Yeah, some people call it corrective shapes as well. But I think one of the here, and the arms are a huge problem with rigging here, deformations, because no matter how good a rigger you are, you never get this kind of deformations. And this is the killer for everyone. Like you can see the arms just look awful, but you can have a corrective shape for that, and it corrects that area of the arm there. So, and rigid body dynamics is like, dude, this constraints for bending, come on, dude. Amos, yeah, this will use. I'm not sure if Maximo rigs work in Houdini, but if you have a rig in Houdini, this is like this should be like a deformant on top of your rig, so it should work with most stuff. I know that Maximo exports the rigs in FBX, so if you can bring that and it's being deformed in Houdini, should be working. So bullet soft constraints for bending, come on, this is amazing. Look at that bending stuff, that's cool. Look at that bending. You can see this takes it to a new level here, which is great. See, this building is totally bending here, but it keeps its shape, but there's like different levels here of bending. This one is, I think this one looks the best of these other buildings, because this keeps the shape and it falls like one piece, because this is where the structure was weakened by the ball, and then when it falls it just starts breaking again, which is, this is so amazing. So yeah, material based fracturing, this is like, what? You can paint stuff and just fracture there like a concrete. This is it's gonna fracture by a material type. Like you can see, this is trying to do concrete or concrete. I'm not sure how you meant concrete, I think. And you can have recursive there. You can see it's fracturing once with these big pieces, and then it's doing another one, and then it's generating the constraints here. It's generating the constraints. These are the constraints for this guy, which is being generated here as you modify this, which is just like great. Now exterior details, you can see They are adding detail to the edges of this guy. You can see, let's go. Frame. There. You can see these edges here are really straight, but then they are these edge details in this frame, and now the edges are all not straight, and that is like a huge thing. Like, this is these edges look real now. Like, just the Voronoi here looks boring, Voronoi boring edges, now perfect edges. So just awesome stuff with those things there. So let's keep it going. You can see they give it a lot more noise, and the edges are totally irregular, which is amazing. Now glass fracturing. Glass fracturing, dude. People wanted this wood just by changing one parameter here. Wood patterns, and they can see examples of wood here being ripped off, and these are the constraints. Glass fracturing patterns. Anyone? This is so amazing. Such a great time saver. It's gonna look amazing. And modeling, it's great. Modeling, it's amazing. These new modeling tools are looking awesome. You can see that multi-edge bridge there. He just selected edges on that side, edges on the other side, and it bridged the whole thing, and it collapsed the edges and all that stuff. Like, yeah. UVs, oh man, the auto seams tool, look at that. It just finds the seams and marks the seams, and then you can just pass that group to the UV flatten, and you're done with UVs. Look at that. So awesome. Oh, I love these training UVs as well. Like that, it's pretty cool. So UVs are just like so fast in Houdini right now to do. It's like so great. Yeah, new Python API for the viewport, which is great. Denoising, this is huge because now we're gonna have the NVIDIA Optics denoiser in Mantra, which it's gonna be great because Mantra, it's a noisy render for some stuff, and some stuff is really huge to rendering in Mantra, but having that denoiser just opens a lot of possibilities with Mantra. Terrains, I really haven't used terrains since they were introduced, but people love them. This is great. Pyro, yeah, I use Pyro a lot. The new retiming tools, they're pretty great, pretty awesome tools to retime your volumes. Oh, this is great. Using color advection in volumes, this is huge. Flip fluids, which is also great. Look at that. That looks beautiful. Yeah, the new whitewater solver looks amazing. New whitewater solver. Look at that. That looks beautiful. Yeah, that splash there looks gorgeous. Look at that. That's beautiful. Wow. Wow. The things that I get excited about. I guess we all get excited about. Games, yeah, exporting here to cards for games, which is great. new plugin for Unity, which is cool. Yeah, it is weird, Dova. It is weird. GLTF import and export, that's great. New Houdini engine for Macs. Cool. Not a Max user, but there's people that use it. And that's it. And I can tell you, the only thing I can tell is there's much more. I dare to say that this is kind of half of it. There's big stuff still to come. Like the last comment here at the end says, and much more. And there, believe me, there is much more. All right, so now let's talk about for each stuff, because I can talk about Houdini forever, and it's not fair that I can't talk about 17, but it's cool. It's coming. It's really close now. All right, so oh crap, I didn't make this bigger. Gonna have to make this bigger. Give me a second. Houdini environment. Let's kill. Give me 1 second, people. There we go. I'm gonna open Houdini again. Try not to screw this up. I was installing RenderMan, the new RenderMan, and I have it installed now. So, but there's still no RenderMan for Houdini. We need to wait for that. So let's do this stuff. Let me put the window where it should be. There we go. So let's do for each loops. All right, so let's go. Man, why is this more harsh? All right, let's do some geometry. Yeah. All right, so let's try to do something here. So for each loops, there are some for each loops here. I need to make this bigger, I think. Let me create it with the Houdini menu here. I don't think the old for each it's here anymore. For each loop with feedback, it's not here anymore. But I ran some events on my system today. 570 score, 570 on CPU, man. That's pretty low. I got like 3,300 in this machine in Cinebench and on Linux. So let's start doing some stuff with for each. So for each nodes, there are a few for each nodes, right? There are like there is 1, 2, 3, 4, 5 nodes, and there is one for loop. So there is different nodes there for. You see, there's 1, 2, 3, 4, 5, and 1 for loop. So what's happening here is it's again like I always say. There's this basically these are the same nodes. this the same nodes with different presets basically. The for loop is basically, I think it's basically the, well, we can construct this from scratch if we put a block, a begin, and a block end. So these two blocks are what makes a for each loop or a for loop. So you can see if I plug that there, I can start using this, but there is an issue here. It's telling me that there's nothing incoming here, but this guy, it's telling me that doesn't know about the input. So you just need to fill these paths here, like here you can see this. Here we should just put this node, and here we should put the end node here, there, so they just know about each other. But that's basically what these nodes are configured with, those basically presets here. These are basically presets. Like the connected pieces, it creates another node actually for the connectivity here, because it's looking for a class attribute later here. But so just note that basically these guys are just presets of creating this block beginning, block end. All right. So let's start with the simpler one, which is basically the for loop actually. So the for loop is gonna do something 10 times. You can see the method is by count. So basically what this loop here, it's gonna repeat. You can see it says repeat and repeat. So whatever you do inside these two nodes is gonna be repeated. Okay. So let's say if we put, let's say, a sphere. If we put a sphere there, what can we do with this sphere? I don't know. Let's try doing a transform. XF. So if I do a transform outside of here and I move this sphere 1 unit in X, you can see, let me make the sphere a little bit smaller. You can see I move this sphere 1 unit from the center, right? I just moved it once. But if I do this in this loop, if I put this here and I see this, you can see now the sphere is all the way here on 10, because this is repeating 10 times. If I repeat this 5 times, you can see it's going all the way to 5, because it's moving. Let's say this is repeating 5 times. The first time it comes here and says move the sphere 1 unit, which is basically this. Move the sphere 1 unit there. Then I need to do this 10 times. Then move the sphere again. Move the sphere again. Move the sphere again. Move the sphere again, until we reach the number of iterations here, and the sphere, it's over here. Same thing if I do uniform scale. If I put to 0.1, it's gonna be scaling down. Let's put 0.9 so we can see it. Scaling down at each one of the iterations here. As you can see, it's getting smaller, or let's make it bigger, 1.1. So it's getting bigger, right? So that's and why is this basically adding on top of the previous space or the previous step, is because we have this gather method, which is the feedback. You can see you set this to feedback, and you need to set it here as well in the input to fetch, because there's fetch feedback, because there's other methods for other things, other purposes, right? So that's how this is working. It gets the does the whatever it's happening here once, and then gets that result, put it again through the loop and then adds the previous or to the previous result, it adds the next one and the next one and the next one. All right, so it's adding on top of that. But if we have something else, like let's say we're gonna copy the points, and let's put a grid here. We're gonna copy to each one of those points, we're gonna copy a grid. And this is let's do something more interesting actually. Let's put Roberto, test Roberto. Let's fracture Roberto. So let's do Voronoi fracture. We need some points. Gather some points like 30, and then do, come on, that I don't want to connect that to there. Now let's remove the shader and color the pieces, visualize pieces. All right, so we have a bunch of pieces of Roberto there, right? And now we want to do something for each one of those pieces, and this is common to do. So let's do a for each, but in this case we can do a few things. We can do a connected pieces because we want to go for each one of those connected pieces. We can do something for that. So let's use the for each connected piece. So now what's going to happen, the connectivity is going to create a class for each one of those primitives, and it's going to give us a result here, and everything it's done for us here. So you can see it's using the piece attribute class, which is this guy's creating for each one of those pieces. All right, so we can do the same transform here, xf, and we can transform each one of these pieces, let's say 0.8. Now you can see this piece it's transforming over here because the center of this transform is in the center of the world here. If I do this and see the result, you can see the whole thing, Roberto, is gonna just get smaller and bigger because we're just scaling but the center of the whole world. So let's put this to 0.8. We want to scale each piece differently. So what we can do here, if we click on the transform, you can see we're seeing one of the pieces only in this state. You can see a different piece if you put the single pass check here, and you can change. You can see this is step 0. You can change this to whatever piece you want to work with. So let's work with let's say that 0. 0 is kind of the center of the world. We want something outside of the center. Let's go with that piece over there, which is way out of the center. So if we scale that, it's gonna scale weird. We want to scale it from the center, which is something that that's useful to do. So we want to position the pivot in the center of this, and for that we use the centroid. So you just use centroid 0, 0 for this geometry x. This is basically says centroid of this geometry x value. So, and the second one is this geometry y value, it's 1, and this geometry c value. So now you can see the centroid of this transform, it's in the center of this geometry, right? So if we go see the result now and remove the single pass, you can see now each piece is being scaled in by the center. And if we modify this, you can see we're scaling inwards there for each one of those pieces. Again, for each one. So what's happening inside here is that we're basically just dealing with one piece at a time. That's the key here. You're dealing with one piece. So if you say, get me the centroid of this geometry, it's talking about that current geometry that is in on the loop. All right, so that's the key of this. Just think about one piece at a time, and then you can actually rotate here. This, let's rotate randomly in the y direction, random. Let's say we can. I'm not gonna be able to do this right now. Let's just rotate it randomly to whatever. Let's put 1 times 360. So now all the pieces are gonna be rotated at the same amount. They look random here, but actually all pieces are actually rotating by this amount. This is not really good. It looks random, but it's really not. They are all rotated the same amount. It's basically the same as just doing this. You can see if I do this manually, they are all rotating the same exact amount. So that doesn't help us. So for dealing with that stuff, doing specific things for each one of those, we have the meta node. You can see if we go to this node at the top here and click it, now we have a new node that I always rename to I, because this is how I think of it in programming. It's the I node or the index. You can rename this to index if you want. Let's put it the name index, but I always put I here because I think about it in programming things. Miguel, you shouldn't be using local variables anymore. Local variables are deprecated, so you're safer if you are using, and I think you can use compile blocks with local variables, so it's better to use Centroid for that. That's why I'm using Centroid. I used to use that $CEX, etc., but it doesn't compile, so I'm changing to that because that's the recommended way. So now this index thing doesn't have things here, but it says it has some detail attributes here. You can see it has an iteration, number of iterations, value, I value, etc. If we go to the geometry view here, select this guy here in the details section, you can say we have iteration, number of iterations, and value. This iteration is the key here, because if we, let me get this parameter so I can select that. If we put the single pass again here and move this, I don't think it's gonna be updating. That's weird. Okay, it doesn't update. So what this iteration value is gonna give us is the current iteration we're on. Actually, it does. It updates after. Parameter. I don't know why, but it updates when I go back and forward. You can see now we are in iteration 4, which is a value we can use to do stuff to different pieces. Remember, you don't always need to do this, the for each block to control stuff. Like Bob was saying, using a for each loop to create cobblestones, so each one has a different size and shape and tilt. You don't really have to use this method. There are different ways to achieve that actually. So we can use the iteration for different things, but let's use it here for the rotation. So since that is a detail attribute, we are going to use the detail expression. And yes, you're going to have to do coding because, or simple expressions, because this is an advanced topic, and if you want to learn these advanced topics, you need to start coding. So we're going to put detail there. Hopefully you can see that. And the detail is asking us for a geometry. So first is the object here. You can see here I'm looking at this part here, so I'm gonna put open a double bracket there, and then it's called index. Close that, and then what attribute we're gonna get from there? I want the attribute called iteration, and it's one single value, so we're gonna put always 0 there. So there we go. Now we have a value here that it corresponds with the current iteration here. Here, this value you can see is now here. So now we can use this value to generate a randomness. So it's gonna change. Each iteration is gonna be a different randomness here. So I'm just gonna multiply that by 360. Because random or rand generates values from 0 to 1. So I need to multiply that by 360 to have a full rotation there. So if we go back to the scene and see this guy, now each one of those pieces have a different rotation. So they are not rotated correctly, and we can see this better maybe with cubes. But yeah, this is how you can do that for if you're doing that for maybe cobblestones, but you can do this. But there's other ways. So let's do another grid, and I'm just gonna I don't know. Let's try extruding this. Select everything and poly modeling, extrude this inset individually. Just want to create a lot of blocks here. I don't want the sides, and then I want to extrude that again just to create a bunch of like tiles or some, and I want to output the back. So I just have these tiles, so I'm gonna randomize the sizes and stuff of this. So if you want to just randomize stuff, this is like really simple. It's not that heavy, but let's randomize it with the for each. So what I wanted to say is that you can actually do this if you have one object, like let's just do a box. This is what I wanted to say, that you don't always let's call this tile, don't always need to do this in for each. So let's create a grid, and I'm gonna put a lot of tiles in this grid. Well, so what I need for that is copy to points. I'm gonna copy this to those points, right? So now we have that because it doesn't have any normals, and it just uses the Z direction to copy. But we're gonna give attributes to the grid. Randomize attribute randomize. We can randomize the normal. And if we randomize the normal, you can see that those guys are already just using the normal that we're generating here to orient themselves. Let me make the normals bigger, like that. So if we modify the, let's say, inside a sphere, but I don't want them to be pointing, let's build the Gaussian. And I don't want them to be like that. So I'm just basically just giving directions in X and Z, not in Y. So now I have that. Look at that. That we have a bunch of tiles that are all rotated randomly. And let me just add a normal here because the normals are being copied as well. So I just have a bunch of tiles that are randomly positioned. If I don't like that, I can modify the global seed here. If I want to give them random sizes, I can randomize the P scale attribute, and you can see we have random Why am I looking at that thing? Hide normals. I have random sizes, random rotations of all those things. So it's simpler to do this. I can control the size, the minimum size and the maximum size here. Of course, they are not gonna interact with each other because they don't care about each other. But you don't always have to use the for each for this. You can just do it with attributes and copy the points if you are using one piece of this. But let's say that your grid here, I'm gonna actually delete this. Let's say that your grid, it's actually it's not one piece, right? It's gonna be different pieces. Like, let's do another Voronoi fracture with some points. Bunch of points, don't do the inside surface. And let's not have too much points. So if this is your geometry, so you can do that, right? You can do that here. Let's just extrude this. Actually, let's extrude them in the loop. Let's say that I want to give them different extrusion as well. So now let's create a for-each connected piece. Again, we're doing the same thing here. Let's do the transform. Let's just copy this guy, so we don't have to do everything from scratch. But now you can see we are scaling each one of those guys. We don't have this value, so let's just delete that parameter for now. So we are actually scaling each one of those pieces. Let's say we also want to create the meta node here, and let's call this I, because I always call it I. Let me copy the expression so I don't have to write everything again. Like that. Let's just this is called I, not index. So now each one of those pieces is rotated differently, and the scale it's not scaled differently. We can actually do the same for the scale, so they have different sizes, but right now we're multiplying by 360, which I don't really want that. You can see now we have a bunch of scatter pieces that are I don't want it to be all the way down to 1, so let's add 0.1 so we don't have pieces that are smaller. Or you can put a fit or 1 expression here and put your range in there from 0.1 to 0.5, and like that. I made a mistake because there's a comma there, and still it's not working. Because why are you not working? Let's see what this looks like. Oh, there's a comma missing here. There we go. Apply, accept. So we have pieces that go from 0.1 to 0.5, and they are rotated differently, etc. We can do this expression in different axis if you want. Let's add something here for randomness, so it's not the same. You can see now they are rotating differently. Before we do that, we can actually poly extrude them, because we wanted to have thickness. We can give it some thickness there, and output the back, and now we have, so each one is going to be have a thickness, and they are rotated in different ways and all that stuff. We can have different thicknesses for this if we use the detail attribute that we created. Let's say we want to use this expression, so we're just basically using the same expression. And you can see now actually the small pieces have small radius, a small scale, and the big ones have bigger because I'm using the same exact seed for this randomness. So that's why that it's working in that way. So let's leave it like that. That looks cool. So you can see now the small pieces have small thickness and the big pieces have big thickness. So you can do whatever thing you want here. Once you understand that you're doing something inside these things, something that some people like to do is you have these pieces. Let's give less pieces here, let's say 10, because we can actually here inside here we can actually do another Voronoi inside, which is something that people like to do. Let's say let's scatter. So remember that here when we're here we're just working on one of those pieces, so we can scatter points on that piece. Let's scatter, let's say 10. Don't relax that stuff, and then do a Voronoi on that piece here. Give the points there, and now we are actually fracturing that piece again in the loop. So if we do that and go here, you can see now each one of those pieces is fractured after we've did the loop. So we fracture it here and then we fracture it again here. So if we simulate this for some reason, let's just simulate this really quickly. Rigid bodies, RBD, fracture object, yeah, packed object, and let's create a flower. So now you can see those things are wrong. This is this is something that happens to people. It happened to me. Like, why is it working like that? Well, the name attribute, it's been done wrong, let's say. So here you can see this guy, it's taking the piece attribute, it's doing some stuff. So we can create the name attribute again here, because here there is a name attribute that the Voronoi creates. If you don't want the attribute to do that, you can actually remove this create name attribute. But what I do is just, you know what, disassemble node, just create the name attribute, which is gonna just assign a name for each one of those pieces. And now you can see now it works as it should be working, because the name attribute with different Voronoi nodes gets different. So now you're doing that. So now you can control how much pieces get Voronoi or fractured. Somebody asked in Facebook, actually, I think that they wanted to fracture just the edges of this, and that's something we could do. Let me just try to do it here. Let me output the side group. I'm just winging this, so I'm not really sure what I'm doing here. So let's do a color to the whole thing of black, and then add a color, not that, and just add a color of red to just the side. All right, so we don't have enough geometry for this, but we could actually give it more geometry, because we are doing all this stuff here. So that we can actually subdivide this thing maybe 2 times. Now we should have something like that, which is not great, but I think it's gonna work for our purpose. Now this second one, we can actually scatter it on the color attribute, and now we should, you can see now we should have just points on the edges of this. And let's give it more, and if we Voronoi fracture that, and now we remove the color here, we are gonna have something that it's gonna fracture the edges more than the inside actually. So now, so we basically just fracture the edges there. If we go here, it's gonna be a little bit heavier. Let's go over there. And there you go. You can see now we have a lot more chunks on the edge of this thing. Of course, this is just, you can see there's a lot of chunks here on the edges. You could do something more beautiful than this. This is just like 5 minutes of work. But yeah, you can do that. You can do all sorts of stuff with for each nodes. But the key here for the for each nodes, just remember that you're using one piece at a time. So, are there any questions? Love the node-based workflow. Yeah. I was thinking of using mountain node to give them the lumpy shape. Sure, yeah, you can randomize that as well if you want to do something like, let's say we want to create a sphere. I'm just gonna use something very quickly. Polygon, make this cabinet like that. Let's say I'm gonna copy this to points to a grid. So I have that right now. I'm gonna just randomize the P scale. (0.1 to 0.5), and I have a bunch of spheres like that. So again, the same thing. You can use the for each connected piece. You can use the name piece for attributes, for stuff that already have a name attribute, like this simulation already has a name attribute when it comes from Sims. So you can use that name attribute to iterate to those. For each number is just saying for 1 to 10, and the for each primitive, which is just what it says. For each primitive is gonna, or for each point is gonna go loop for each one of those points. So it just the variations are really simple to understand. So here we can do the for each connected piece again, and we can put the mountain here, the mountains up here. And again, think you are adding mountains up to each one of those. But if you have them like this, since each one is in a different place, the mountain sub is basically global. It expands to the whole world. So here each one is gonna be different already. You can see each one is different because it's in a different place in the world. So if you just add the mountain sub to that, it's just gonna do that. I'm not sure if it's gonna work if we do it like this. Would it work if we just do it like this? Kinda. Yeah, kinda does the same, because as I say, the mountains up, it's different for the different rocks and stuff. We can control whatever we want here. If we want to, we have the P scale attribute. We can put the P scale attribute here, and each one of those is gonna have, let's multiply that by 10 maybe. I think I'm not grabbing the P scale attribute here for some reason. Let's go to the geometry view. Let's hide this guy. P scale 0.2. I don't think it's gonna like my P scale attribute here, which is a shame, but we could do it with a detail if we get it from here. Whatever. I don't really care much about. Oh yeah, I know the p-scale attribute is not copied to the copy point attribute. Yeah, it is copied. Weird, because it's there. But yeah, this is not. No, this is not gonna work. I know why. Just delete this guy. So you can randomize. Let's randomize with the same thing. Let's call this J. We can just get the detail attribute. Detail J. We get the iteration 0. So now this is a 99. Element size is 99. That's pretty big. That's pretty big. But some of them will have. Oh yeah, let's generate a random for this, not leave it at that. Randomness for that. Now you can see, there we go. So the big ones have more. The element size of the mountaintop is bigger than the smaller ones here, which is good. I don't think it matters actually, because we're not actually multiplying this by the p-scale, which is, I'm just talking stupidity there. So it's just random for each one of those. Doesn't matter how much. And then if you don't like it, you can just put it again a feed range, or just add some number here to make it a different seed here. But you can see, yeah, you can randomize that for each one of those rocks there. Although adding the mountain sub directly, if your rocks are all over the place like this, is there a expression for random rotation? You can use random. I already did that. Or you can use the normals. Randomize attribute, randomize the normal like this. I'm randomizing p-scale here. I can randomize the rotation like I already did here actually. Pay attention, guys. So you can see we're already randomizing the rotation here. It's not expression exclusive for rotation. It's for everything you can use. We're just working with parameters here. We're just working with numbers here. So there you go. You could actually multiply this guy by the p-scale attribute if you manage to get it to work here, but I don't think it works here. So I would get it with the point attribute 0. Then we need to get the ptnum. I'm gonna explain what I'm doing in a second. Get the p-scale, and let's get attribute 0 from there. There we go. So all right, so now what I'm doing here is getting multiplying the element scale by the p-scale, the point scale, the p-scale attribute that we created over here. So now smaller ones are having like more are more spiky than big ones actually. So you can control that there if that's what you want. If the smaller rocks have less are more spiky, and we can do that for the height parameter as well. And you can see now smaller rocks have more height than the bigger rocks, or just it's being randomized as well, because it's being multiplied by that p-scale attribute. Let's just not do it for this, but yeah, that's how you can do something like that. You can randomize any parameter you want, and that's it. Any questions? Hey, Bread of Life, hello to Wayana. Good night. Mocked up. We already did that. We already watched the H17 sneak peek video. We did it at the start of this stream. Oh, thank you, Bob. Thank you for that. Is there any questions? Because I think we're gonna be done for today. So again, basic stuff about for each nodes. They're just work with one piece at a time. So we could do this, and then after those nodes, do another for each connected piece, and do something different here, like rotating them, like somebody said, rotate them differently. So let's put a next form transform there, and we can rotate them, let's say in the you know what, let's scale them in a direction. So let's say first let's scale in the y direction, like this. See, we're scaling one at a time, but again, we put the pivot at the center, centroid. And we scale it down, let's say a 3, but we wanna, let's call this K. We want to rotate them, scale each one differently. Let's do the detail attribute, get the detail from that K node that we have there. So we just get out of this node, put the K node, get the iteration attribute, get the 0 index, and now we're gonna have a huge scale because we want to randomize that. Use that value for the randomization, plus 0, 1, so there's no 0 values there. Now you can see some of them are flat, some of them are big, like these ones are big, those are all flat. And we can, after this, we can rotate them, doing the same thing. We can even grab the same attribute here and put it in the rotation. Let's rotate them in C. Let's give it some variation here, times 360, and let's give it some randomness there. We forgot to give it the let's copy this parameter to the pivot, so they are rotating from the center. Paste expressions, and there we go. Now they are all rotating from the center, and they are rotated differently in the C value. And we flatten them, and we could do these two things in one node, but sometimes I just make two nodes for clarity. If you had two nested for each, would it do the outer one once, then inner one how many times in the set? 2. If you have two for each nodes, they are that's because that's a good reason to get into programming, guys, because you just understand this stuff because you do it in programming. LearnDay 67 for each. Let's do nested for each. So let's do a for each number. We're gonna do something a number of times, and let's do a cube. A box, actually, box. It's not called a cube. So this guy is using, it has this for each node here because it's using those, it's counting the iterations, right? So if we do this thing, let's put a transform again, I guess, and move this one unit in X. What's happening here? It's crap, this is not what I actually wanted. Let's remove this. For each loop, I wanted this for each loop. XF, so translate once, and this runs 10 times, right? So it's moving from the center of the world 10 times. You can see it's what's here. Let's put the we already discussed this. It's moving it 10 times because this thing is moving, it's iterating 10 times. But let's say we want to iterate just 3 times here. Let's say 4. If we put another for each node inside this one, let's create another for each loop just to make it this simple, and we put this inside here. So now this is running 10 times. So where's our cube? So it's over the way over here in line, which lines is this? 40 actually. So if you count them, this is 4 times 10, it's 40, right? So what's happening here, what's happening is it's saying, let's color this loop. Let's change the color of this loop so you can see that we have 2 loops here. So Houdini, it's coming and saying, all right, I have this loop, I have this cube. So this loop is gonna repeat 4 times because it's gonna go here down 4 times. But when it gets here, now this loop kind of takes over, and this loop repeats 10 times for the first time this loop runs, right? So this loop is at loop 1, and this is at loop 1, and then it repeats 10 times here, and then goes out here, and loop 1 finishes for the orange loop, then goes back for loop 2, and then it repeats another 10 times here because this loop is repeated 10 times, and then goes out here, and then goes back to for loop 3, and then repeats another 10 times here, and then goes out to finish loop 3, and then goes back up to loop 4, and then repeats another 10 times here, and then goes out to loop 2, right? So it's really simple to actually visualize this once you have these nodes like this, because if you say, okay, this one is repeating 4 times and this one is repeating 10 times, then it comes here. The first time the orange one is going to repeat, here it's going to repeat 10 times. So hopefully that is clear. It's not that complicated, but that's how that works. If you can have another loop inside this loop, you can have different loops inside different loops and stuff like that. Alright guys, I think that's gonna be it for today. Hopefully loops are clear. I want to do more training on loops because people still get hang up with loops, and I think this was a great intro to them. Maybe I can grab a piece of this video and just put it as a standalone video so people can see this about loops. Is it possible to use multi-parm block with RAM in for each? I don't know, and I don't know how to pronounce your name, and I think that's a Russian name. I don't know if it's possible to use multi-parm block with ramp in a for each. I haven't tried that. Maybe if you have an example, we can discuss it. Go to Discord, actually. Go to the Discord server and share it there, and we can discuss it there. If you can have like an example or what is that thing called? A screenshot or something. If you go to the to this video, YouTube makes training, there should be the link for the Discord in the description. Here you can see it. There is the don't want to be live. There's the link for the Discord. Go there, you can chat with us, and we can try to see what you're trying to do there. Alright guys, that's gonna be it for today. hopefully for loops are clearer to you guys. Please, if you want to support us, go buy some of our training, support us on Patreon, and I will see you guys next week. Alright guys, I'll see you guys later. Have a great week. Do you have any tutorials planned for future? Yes, I have a bunch of tutorials planned. I got a bunch, but I'm just finishing some stuff to make some new courses and stuff. Alright, see you next week. Have a nice week. I'll see you guys later. Thank you for being here. I really appreciate it. I'll see you next week. Keep learning together. Let's keep learning together. Bye.